Alright, we're going to kick off our unit on congruent triangles, and we're going to start out by taking a look at polygons in general. We start out with the definition of a polygon. And you might be used to these typical shapes. Most shapes, in fact, are polygons that we would think of. The key to being a polygon is that it's a closed shape. So you can't just have a bunch of lines open like this. That is not a polygon. You also need to have straight lines. So one of the most common shapes that we would be used to, like a circle, is not a polygon because it does not have straight lines. And then finally, last big piece of being a polygon is it needs to be on a plane. Now usually we take that for granted because we draw most shapes on a piece of paper, but it needs to be something that sits flat on a plane. Some different prefixes that you're going to see when describing different shapes: tri, quad, pent, hex, hept, oct, non, dec, and dodec. And I put the typical name that you'll see for a shape with that many sides. So a triangle obviously is something that has 3 sides. Quadrilateral, we'll study those more later, that has 4 sides. A pentagon you might recognize as 5 sides. Hexagon, 6. Heptagon, 7. An octagon, pretty standard stop sign, has 8 sides. A nonagon, now these are probably less familiar here, a nonagon has 9 sides. A decagon, you might think of a decade being 10 years, so a decagon has 10 sides. And to throw you off a little bit here, a dodecagon is something with 12 sides. It is not an 11-sided shape, if you were guessing. And then down here to a regular polygon. It's a polygon just like above. The key is that all the sides are equal. So if you think of a stop sign, it's an octagon, it's a polygon, but all 8 sides on a stop sign have the same length, so it would be a regular octagon. Notice that when they have the equal sides, you're also going to have equal angles. So you think of something like an equilateral triangle, that would be a regular polygon. Let's jump down here looking at these different shapes. A triangle obviously has 3 sides, and this question doesn't really make sense for this first one. How many triangles are inside of a triangle? Well, 1. And the sum of the interior angles of a triangle, if we added up all 3 angles inside the triangle, right here, and right here, that's always going to equal 180 degrees. And that's something we're pretty used to. Now when we go to a quadrilateral right here, we have 4 sides, but the number of triangles inside, that's something where if I were to split this up here, I now have 1 triangle and a second triangle. So I can form 2 triangles out of a quadrilateral. And we'll talk about why I'm counting triangles inside in a moment. Some of the interior angles of any quadrilateral, the easiest one to think of is a square, where you have 4 90-degree angles, and that adds up to 360. Turns out all quadrilaterals, no matter what their shape, all the interior angles are always going to add up to 360. In the same way that every triangle, no matter what its shape, all the angles add up to 180. In this next one, we have a pentagon here. It has 5 sides, and the number of triangles we can create inside, if we take these corners here, we have 1 triangle. We can split this up here. My lines aren't perfect. We have a second triangle, and then we have a third triangle left over. So we get 3 triangles out of that. You're starting to notice a pattern here. As we go up by 1 here, we're also going up by 1 here. These are always 2 apart. Now it turns out the sum of the interior angles of every pentagon is actually going to be 540 degrees. And let's keep following this pattern and see if we can catch on. Here we have a 6-sided shape, a hexagon. Number of triangles inside, we're guessing probably going to be 4 based on our current pattern. Let's see if we can find them. So there's 1, there's 2, and we can split that middle, 3 and 4. So 1, 2, 3, 4. So you can form 4 triangles. And there are lots of different ways to break it up. You don't have to break it up the way I did. But no matter how you do it, you're always going to get 4 triangles. And the sum of the interior angles is actually 720 degrees. What you might notice here is if you take the number of triangles inside and multiply it by 180, you're going to get the sum of the interior angles. One triangle, 180. Two triangles, you get 2 times 180, which is 360. Three triangles, you get 3 times 180, which is 540. When you have 4 triangles inside, the sum of all those interior angles is going to be 720. And by that same pattern here, when we have a 7-sided figure, we're going to have 5 triangles inside, which is going to add up to 5 times 180, or 900 degrees. And then finally, we have an 8-sided, we have an octagon. We have, there's going to be 6 triangles inside. Let's just make sure we can find them all. We've got 1, 2, 3, 4, 5, and then 6. So 1, 2, 3, 4, 5, 6. And that's going to give us 6 times 180, which is 1080 degrees. So the pattern here, if you're looking at the number of sides, you have to take away 2 to get the number of triangles. Then you have to multiply it by 180 to get the sum of the interior angles. So we take 180 times our number of sides minus 2. Remember to do that in parentheses first, because otherwise you're going to get a different answer. So take your number of sides, take away the 2, that'll give you how many triangles, multiply it by the number of degrees inside of a triangle. Skipping on to a slightly different but related topic, exterior angles of polygons. An exterior angle is this outside angle here. So if you were to draw this line continuing outwards and then draw this angle, or if you were to take this angle here and draw this angle, or this line here and draw this angle, these would be exterior angles. And when you take that angle plus that angle plus that angle and add it up, it's always going to equal 360 degrees in a triangle. And what's interesting is if you do that for a quadrilateral, you take that angle here, this angle here, this angle here, and this angle here, you add that up, it's going to equal 360 degrees in a quadrilateral. And if you do that in a pentagon, and you do it there, and you take all these exterior angles and you add it up, surprise, you're going to get 360 degrees again. You'll notice that as the shapes have more sides, each of the exterior angles gets a little bit smaller. You can see these are pretty big here. These are a little bit smaller. These are a little bit smaller yet. By getting a little bit smaller with each new side, the total ends up staying the same. So the exterior angles of any polygon always add up to 360 degrees. So first question here, practicing, what is the sum of the interior angles of a hexagon? Well, a hexagon we know is 6. And if we want to know the sum of the interior angles, we have to figure out how many triangles. So we take away 2 from that. So we have 6 minus 2. And we take that number times 180 degrees, because that's the sum of the interior angles of a triangle. So we have 4 triangles, 180 degrees per triangle. That equals 720 degrees. So that's going to be the sum of the interior angles. Second one, what is the number of sides in a polygon if its interior angles have a sum of 2,520? Here we're going to work backwards. So we're going to use what we know to be true, the fact that the sum of the interior angle is 2,520, and we're going to set it equal to our formula that we know. We know that we have to take the number of sides minus 2 to get our number of triangles. We know we have to multiply that by 180 to get our sum of the interior. And this time, instead of going from the left side to the right, we're going to work backwards. So if we take both sides and we want to solve this for n, we want to get n by itself. N is trapped in parentheses right now. So the only way we're going to free this, we could distribute, but that's going to probably take us longer. The fastest way is to divide both sides by 180. So let's go ahead and do that. And when we do that, we cancel this 180 here, leaving just n minus 2 on this side. And on the other side, we have 2,520 minus 180. So pop that in your calculator. And trusty Google says that that's going to be 14. So now that leaves me with, we're not done yet, n minus 2 equals 14. So I have 14 triangles, But really, I still have one more step. I have to add 2 to both sides because I want to know how many sides are in this shape. So n is going to equal 16. So what is the number of sides in a polygon? That's going to be 16 sides. Third one down here, what is the measure of one interior angle in a regular pentagon? Well, the only way we're going to get the measure of one is if we find the sum of all of them first. So let's go ahead and say pentagon is 5. So number of triangles is 3 times 180 degrees per triangle, and that's going to give us 540 degrees total. So 3 triangles, 180 each, 540 degrees inside. Now we want to know the measure of one interior angle in a regular pentagon. Regular means they're all the same. So all the angles are going to have the same measure. So if I just take this 540 and divide it by the 5 sides, or the 5 angles, when I do that, I can punch that in my calculator or do that in my head, and I get 108 degrees per angle. So the measure of one interior angle is going to be 108 degrees. Jump down a couple more here. What is the sum of the exterior angles of an octagon? Well, trick to this one, exterior angles, and we're talking about the sum. Doesn't matter what shape it is, it's going to be 360 degrees. And then the fifth one, what is the measure of one exterior angle of a regular octagon? Regular again means they're all the same. Octagon means there's 8 sides. So if I take my total, my 360, and I divide it up into my 8 different angles in that regular octagon, I'm going to get 45 degrees per exterior angle. So on my octagon I have this shape here, and each of the exterior angles, meaning this angle out here, each of those is going to be 45 degrees.